Okay, so this first bit is going to be a bit of a recap of the things that you've just met in the starter. And then the other videos which follow this are all going to be examples of how on earth we work through doing this in real life for the skill that we're going to learn in this first task. The good news is I know there's a lot of videos in this first section, but I've only put one video up for the other two skills because this first skill is like our key skill and everything else kind of builds off it. So that's why I focused in on making sure we've got lots of content for this first skill. So in the starter, we had two equations. We had the equation minus 4 cos of x plus 3 sine x equals 0. And our second equation was almost identical, but on the opposite side of our equals sign there, we had a number which in the question I asked was 0.2. Now, we want to see the difference between these two things. The difference, if we just spot the difference, is that this is equal to 0 and this is equal to 0.2. Let's have a go at solving and see why that matters. So up here, I'm just going to add 4 cos x to both sides. So I've got 3 sine of x equals 4 cos x. Well, I'm going to divide both sides by cos x. So I end up with 3 sine of x over cos of x equals 4. I'm then going to divide both sides by 3. So that gives me sine x over cos x equals 4 over 3. And so we get, when we finish doing sine over cos, remember a little identity, sine over cos is tan of x equals 4 over 3. That is something we can totally solve. So that is actually very like some of the examples we did with our identities, where we went to a tan x. We can solve this. On the other hand, if we try and play the same game down here, so we're adding 4 cos x to both sides, well, that's going to cause a problem because now if we try and divide by cos x, we get 3 sine x over cos x again. But we try and divide this by cos x, we're going to get a horrible mess because that goes over cos x plus 4. Oh, that hasn't worked out nicely. We've not got rid of our cos x. And the answer to that is that there is no nice way to solve this using the methods that you have met so far. And so learning how to deal with this bit and turn that bit into something that we can operate with is going to be our key skill within this task, and then being able to solve that whole equation is going to be task 2 in what we're looking at today. Now this actually, if you've watched my slightly lengthy video in which I play some music and talk to you about maths, you'll have seen that this is a sort of very straightforward-ish version of a wave equation for, say, sound or like electricity. So this kind of equation comes up a lot and is something that is useful to know how to deal with, and certainly can't just be dealt with straightforwardly. We need to be able to convert this to something that we can operate with. So on to thing 2 in my starter. Thing 2 in my starter was I was talking about k sine x over k cos x. And this is very much going to be a building block that we're going to use. We're going to see this in our calculations in the videos. The next 3 videos, this is going to come up every single time. So we do k sine x divided by k cos x. Well, the k's cancel out. So all we're left with is sine x over cos x. And from what we know about trig identities, that is tan x. So that is going to be a really useful fact. We're going to use that multiple times in what is coming up. And the second one that I asked you to have a think about was slightly lengthier. We had k sine x and we squared it, and we added on k cos x squared. Well, if we do that, this first bit gives us k squared sine squared x. So I'm just squaring each of the things inside the bracket because they're multiplied, so we don't need to do a double bracket or anything because they're just multiplied together. which is why I can square each one individually. When we've got that, we could factorize out the k-squared. So that's equal to k-squared lots of sine squared x plus cos squared x. In brackets, but sine squared plus cos squared, that's another trigonometric identity, is just the same as k squared. And both of these facts I'm going to use, and actually having in mind why these work is handy, because in a minute I'm going to kind of assume these two facts. I'm going to use them fairly much in the middle of the thick of it with a lot of other maths. So I wanted you to see why they're true separately, so that when I use them in a moment, you can kind of follow where I've got all of that from. So that's just a little bit of an introduction, recap of what you've just done at the starter. The next 3 videos will give you examples of the kind of maths that you're being asked to do in the questions.